All right, class, I'm sorry I'm not able to be there today, but I thought I would just generate a quick video, go over some of the stuff that was related to the lesson. So to start with, the warm-up was related to this idea of different atoms either gain or lose electrons to become stable. So if you think of lithium and fluorine here. So lithium has 3 electrons, fluorine has 9 electrons. Now, to be stable, and I need to kind of move this, to be stable, we need lithium could either lose 1 electron or it could gain 7. Now, the likelihood that lithium is going to be able to get 7 electrons from a bunch of atoms is pretty low. And it just wouldn't have the protons to be able to pull those in anyway. So then so it would lose an electron. Fluorine, on the other hand, would gain 1 electron because it has 7 electrons in its outer shell, and having 8 would make it have a noble gas configuration similar to a neon atom. And so that's the tendency. That's the tendency of how these things will behave over time. Now, as we go along, I want you to actually answer. I'm going to go through a few questions here, and I want you to just take notes as we go along. I may ask you to pause the video as we go along, but just kind of follow along. So our first question is, how is chemical stability related to the arrangement of electrons in atoms? So go ahead and pause the video, and I want you to talk to your neighbor for just a few seconds regarding that. Okay, welcome back. And with that, so this idea of how the arrangement of the electrons in the atom. So by having a full shell. So when we think over to the periodic table, okay, so you're thinking about that periodic table, the most stable elements are the noble gases, right? The noble gases over here on the right-hand side. And they are stable because their outer shell of electrons, the part that interacts with other atoms, is full, and so therefore interacting with other atoms is a low priority. Where atoms over on the right-hand side, okay, over here, all the alkali metals, well, they all have 1 electron in their outer shell. And so by losing electrons out of that shell, they can be more like the noble gases over here. And so that's the tendency, that's the trend for different groups to lose certain numbers of electrons according to how they might change to a different configuration. Okay, so now let's move on to our next question. So here's our next question. When atoms gain or lose electrons, they form ions. Ions are atoms that carry a net positive or net negative charge. And this is something that can be very confusing. So let's go over to the board here, and let's see if I can actually pull this off. But when you think of, let's take fluorine for instance. So let's say we have fluorine. Okay, so fluorine has, for the number of protons, fluorine has what? It has 9 protons. Okay, and let's say we have fluorine 19. Okay, fluorine 19 is what we'll say we have. So that's going to give it 10 neutrons. Okay, not overly important. But when we think of its number of electrons, okay, so its number of electrons is 9 as well. So we're going to put the first 2 in the inner shell, and then in the next shell, we're going to put a total of 7, because that's what we have left. Okay, so we have 7 electrons in the outer shell there. Okay, so what that means is, so the number of protons is 9. The number of electrons is 9. Okay, the charge of a proton is positive, right? So that means we have a total of plus 9 charge coming from all those protons in the nucleus. And then as far as the electrons go, we have a total of 9 electrons, and each electron has a negative charge. So what that means for us is that the overall charge of this atom is 0, right? So it's neutral. Now, the thing is that typically fluorine likes to gain one more electron. It likes to get one more electron. So if it gains one more electron, what happens to our number of electrons? Okay, our number of electrons goes from being 9 to 10. So if that's the case, then our total number of negative charges from electrons is minus 10. So then for fluorine, the overall charge for fluorine is going to be minus 1. So that's why we would write the fluorine ion as being F minus, because it has a minus 1 charge. And this is something that's can be really challenging, because when you think of adding something, you often think of the charge or something becoming positive. And when we subtract something, you think of things being negative. But it's reversed when we're talking about ions, because when we add electrons, we added one extra electron where the negative charge is increasing because electrons are negative. So if we add a negative particle, the overall charge is going to go up. And if we add positive, or if we lose electrons, so let's look at like sodium. So let's make sodium here. So let's say we've got sodium is going to be 11 protons and, I don't know, we'll say something like 12 neutrons. Okay? So if it has 11 protons, it's going to have 11 electrons. So we've got 2 there, 1, 2, 3, 4, 5, 6, 7, 8 electrons there, and then it's just going to have 1 electron on the outer shell, right? So that 1 outer shell electron. So what that means is sodium tends to lose that electron, and it could actually go to the fluorine that we were looking at earlier. Okay, but let's do the number. So number of protons here would be 11 protons. Number of electrons for the neutral atom would be 11. Okay, that's going to give us a plus 11, minus 11, a total neutral charge. But when it comes to if sodium loses an electron, if it loses an electron, okay, so this is the idea that we're subtracting electrons, then the overall negative charge is going to be 10, while the number of protons has not changed, so therefore the overall charge of the sodium has now become plus 1. And so we write it as Na plus. So positive, so lose electrons, the overall charge becomes negative. Gain electrons, the overall charge becomes, sorry, I said that wrong. Lose electrons, the overall charge becomes positive. Gain electrons, the overall charge becomes negative. Okay, let's go back over to here. So the idea of, so you can have a net positive or a net negative charge. So where does that take us next? Next, when atoms lose electrons, they have a positive charge and are called cations. So if they lose electrons, they're called cations. So that means sodium, which loses electrons, things that lose electrons are called cations. Okay, that's just a new vocab word there. So positive charged things are positive, or are called cations. And then when atoms gain electrons, they have a negative charge and are called anions. So our fluorine atom over here is going to be called, so this is called an anion. Okay, and that's just a vocab word regarding what we call negative ions. And then lastly, this idea of ions have electron arrangements resembling those of noble gases. So they're losing electrons or gaining electrons to be like the noble gases.